Welcome to another edition of the Offset Podcast. In this episode, Robbie and I are going to talk about DIY hardware for post-production. Stay tuned.
This episode is sponsored by our friends Flanders Scientific, who are leaders in color-accurate display solutions for professional video. Whether you're a colorist, editor, DIT, or broadcast engineer, Flanders Scientific has professional display solutions to meet your needs. Learn more at flandersscientific.com. All right, Joey, in this episode, we are actually beginning a two-part little mini-series on, I think, probably one of your favorite life mantras, and that is do it yourself, right? It's well known by those who know you that you are the king of DIY. Why bring a motorcycle to a car to a mechanic or dealership when you could do it yourself? Why buy something off of Amazon when you could just 3D print it yourself? Why do any of these things with the help of other people when you can do it yourself? Now, I tease. It is one of the things that I've, in the time that we have worked and known each other, that I admire about you the most, and that is my inclination is, I need something, let me go on a website somewhere and order it, right? And, it's the wrong thing, well, start a return. I'll try to find the right thing and return it again. One of the things I've learned from you, and I think this comes a little bit from cars and your mechanic level, being a mechanic, but is that, a lot of things that we do is super easy to do it yourself, and you can actually customize and create in a lot better way than you can. So in this first part of the series, we're going to talk about sort of DIY hardware for post-production. And in part two, we'll talk more about DIY software approaches, things like custom scripting and things of that nature. So let's start out by talking about the big picture here. And what I just sort of hinted at is that, why are we going to DIY in the first place? I know kind of what you're going to say, but I want to hear it coming out of your own mouth. Why is DIY appealing to you versus buying something prefabbed or whatever? What's the motivation in your love of DIY?
So, the primary motivation is probably customizability, right? I think a lot of people would assume the motivation is cost, right? I can make it myself. I'm going to save some money. I hate to break it to everybody, but in a lot of cases, that's not true. You're going to spend more money buying all the junk and more time, learning how to use everything and building it yourself, than you would if you bought something off the shelf. But what you've made will suit your needs directly and better than, in a lot of cases, anything you can buy off the shelf. And especially some of the stuff we're going to talk about today with things like ergonomics and hardware for grading and things like that. We're interacting with these devices all day, every day. So small annoyances in ergonomics can really compound and add up. So being able to dial in exactly what you want in a part is super useful. And it's a ton of fun. It really gets your brain working in other ways. It's a good way to kind of expand your horizons, and it's just useful for things outside of work as well. But mostly my primary motivation is customizability.
Yeah, and I tend to agree with that. I mean, I had my first taste of this, I think, and I think a lot of people probably realize this in our relationship, that I tend to follow Joey's lead a lot with this kind of thing and get interested in some of these things because he's like, I just made this doohickey, have at it. And actually for me, that parlayed itself into doing something that you're not interested in, but I am. I started doing this with guitars, right? It was like, well, geez, guitars are not that complicated of machines. I should be able to figure out how to design a shape, how to CNC a shape, how to build such a thing. And first of all, you're 100,000% correct in that. Generally speaking, the DIY approach does not necessarily equate to cost savings. And I'm absolutely giving you a testimonial that is 100% the case with doing a custom guitar. I've spent exponentially more money on trying out parts and techniques and stuff like that. But also there is a level of satisfaction by looking at something and going, I designed that, I made that is mine, and it's one of one potentially.
Yeah, and when it's something, like we're talking about with post-production and the stuff that we interact with at work every day, it's really nice to be able to have your workspace kind of somewhat made up of stuff that you have just tuned to exactly what you want. And you're using it every day, and it is very satisfying, and it makes you, I think, faster because you know it intimately.
Well, speaking of which, for those astute watchers who have noticed that over here, gone are the guitars, right? I didn't get rid of the guitars, by the way. I just moved them into a separate room because I have too many guitars that I needed a whole separate room for my guitars. And I've replaced that. You'll notice down here some filament on a bar here. One of the things that Joey's got me into, and this is a great segue for our first part of this conversation, is Joey over the years has got me into 3D printing. Now, Joey, I love you and hate you for this because on one level, 3D printing has been like the greatest thing that's ever happened to me because it's sort of like I've changed my whole mindset, right? I'm sort of like, oh, well, I could print that. I could print that. I could print that. The hardest part about 3D printing is not the printing. The hardest part about 3D printing is designing or finding parts. So let's start there, Joey. 3D printing, because I think this is something that is obviously near and dear to you. I think you have 2 or 3, 4 printers now, something like that. I got a couple printers going. Tell us the basics of 3D printing, how it works, and why, for what we're talking about specifically for stuff in post, what uses it really has.
Yeah, 3D printing is probably the most useful DIY hardware thing you're going to find for post-production and color grading. And what 3D printing is at the basic level is you are literally taking a digital 3D file and then having a robot manufacture it into a physical 3D object. And the way this works is, Robbie mentioned the spools of filament behind him. You can see them. They are rolls of 1.75 millimeter wide plastic. That's it. Meltable plastic. And what the 3D printer does is it feeds that roll, almost like wire thickness roll of plastic, through a heating element, and it spits out melted plastic, and it's on a little robot that draws a shape, right? So if you wanted to make a pipe, for example, you would draw a circle, then you would move up a very small amount, draw another circle, move up again, draw another circle. So you're working in layers, and you're literally printing out plastic layer by layer by layer to make a 3D shape final product at the end. There's lots that goes into this, but your basic ingredients are you start with a 3D file, then you put that in a software called a slicer, which does exactly what it sounds like. It takes your 3D file and slices it into 2-dimensional flat layers. So imagine just taking a knife and slicing through 1,000 layers of an object, and then just puts that into computer code for the 3D printer to execute. If you ever sit there thinking, I wish I had this object, you should have a 3D printer.
So I used to not think that, because I think my first exposure to 3D printing was I didn't want to spend a lot of money. So I started with, an extremely basic, what they call a bed slinger type printer, right? And it had a small build volume, so I couldn't print bigger objects. And 2, it required a lot of tuning, and so it just kind of turned me off. I was like, I'm not going to get good results of this. So therefore I was like, cool, it's great for printing little, fidget toys or something like that. But the other thing I will tell you is that it is easier than ever to buy an off-the-shelf printer and get killer results. When Joey started this, and when he was initially telling me about this 10, 12 years ago, I was like, yeah, sure. And the results were like, you could clearly tell that was 3D printed, and you could clearly see the struggle on somebody's like Joey's face of like, well, I was tuning the printer for 12 hours and I finally got it to print right? These days, I mean, the printer I have back over here in the corner, I have a little phone app. I download something off the internet I like. Cool. Print, do it all remotely. It's got a camera in it. I can look at it remotely. It sends me a text message when it's done. I go downstairs. Okay, cool. Thing's done. Right? You joke about this sometimes, but it's literally like the Star Trek replicator, right? Like I'm just waiting for one of these days we're gonna be that cup of hot, Earl Grey, right? It's gonna be coming out of a printer. So let me ask you this, Joey. So the basics of 3D printing, melting plastic in a design, computer code understands it. Give it a couple hours, you get the thing. But how do we get from here, the idea in my head, to the thing that's spit out of the printer, right? I think the thing that's kind of challenging, and you say this in your best Back to the Future voice sometimes to me, is you need to think fourth dimension, right? So I think the part of this goes to, and one of the reasons I think it's intimidating people is the design aspect. Can you speak to that a little bit? What is that path like from idea, design to print?
Yeah, the first thing is the idea. And I want to talk about that a little bit because one thing we haven't really gone over at all is what am I doing professionally in my suite with 3D printed
Yeah,
stuff? You know,
yeah.
what am I actually using every day that I've talked about that we 3D printed? For me, the bulk of it is peripheral holders, right? So I have 6 Stream Decks on my desk right now. And the Stream Deck in and of itself is a bit of a DIY hardware, right? Because you can define what all the buttons do
Right.
and what the workflow that it's kind of using is, right? So you can build up a tool set on that Stream Deck that's in anything that you want. But the problem I kind of got into is the Stream Deck comes with a little stand, right? It sits on your desk and it's kind of at an awkward angle. I never really liked where it was sitting. I couldn't position it where I wanted. So, you know, when you're hitting 1,000 buttons a day, that adds up. So, kind of the first things I 3D printed for the suite were Stream Deck holders. So, I've got a conventional Stream Deck holder that holds 2 Stream Decks, 2 of the original ones, that is the exact same height as the control deck on the mini panel. Then, when the Stream Deck XL came out, I designed a much more advanced XL holder that holds the XL on your desk at exactly the same height and angle as the top screens of the mini panel.
Yep.
So now I've taken an off-the-shelf piece, the Stream Deck, and made it a much more integrated part of my mini panel setup. And I'll tell you what, like going through day to day grading on this setup, it has saved me so much time being able to have these additional pieces exactly where I wanted them.
I agree with that. I know you have gone before, but I'll give you my own examples of this kind of thing. So number one, stance holders, that's pretty low hanging fruit. I've done some of the similar things, used some of your designs for Stream Decks, etc. Where it's really what I like to think about 3D printing stuff is I have a problem to solve. How can I print? How can I fix this problem relatively quickly and customize it? So, for example, the lights that are on in front of me, I 3D printed light holders for all of these lights that I have on, right? I have, for example, the little iPad that I have over here for show notes and stuff. It's a 3D printed iPad holder, right? I didn't want to spend $100 on a stand from, a store or whatever, Amazon, so I 3D printed one. But more practically, like it goes into fixing other problems. Just this past weekend, I was installing something in my machine room rack, and the particular equipment I bought used, it didn't have rack rails. Okay. So I had rack ears for it, but I didn't have any rack rails. So what was happening was the back of it was sagging just a little bit, right? I 3D printed these supports that tie into the rail on the back, come into the rack about 3 inches, and just lace right under the back of the rack, right under the item to give it a little extra support so it's not sagging, right? Took me about 15 minutes to print it. Problem solved. I would have been Googling for days to find something that was suitable and cost efficient to do that kind of fix. I have a little Elgato teleprompter in front of me. I broke a plastic piece off of it when I was installing it. It's a thin little piece of plastic, no big deal. Didn't want to have to order another one because it's kind of expensive. Just took a measurement with a piece of calipers, printed a new little round piece, put it onto the VHB'd it, taped it to the back of the prompter. Band-Aid, sure. Problem fixed, solved. It's not going anywhere now, right?
Exactly. And it just does kind of open your mind up to thinking fourth dimensionally, like you said. You look at problems in a more solvable, direct way. And so yeah, let's talk a little bit more about that whole process, like you mentioned. So we've got the idea. We talked about that. We need to turn that idea into a 3D object. And there's a couple approaches to this. Learn CAD software.
Yeah.
That's the most difficult approach, right?
Certainly.
I do highly recommend it. There's great tutorials online. You can do very basic CAD very easily. Like it's a lot easier to do CAD of something that isn't pretty than something that is pretty. You can make
let me just interject here because there's actually different levels to this. Because are you designing a piece of life and death hardware that has to be precise enough to put in a wind tunnel or whatever the case may be? Probably not, right? So in that case, you don't have to use the $50,000 a year, AutoCAD software. There's levels to this. I know you're a big fan of Fusion 360 by the guys at Autodesk. Fusion's great. I've really started to learn it, but still hurts my head a little bit. I'm using something called Tinkercad that is like essentially like a pretty cheap design software. It does a lot of the heavy lifting for you, takes a lot of the engineering parts of that software, kind of hides them away a little bit, and I can get to really good results really quickly. I can't necessarily do things within the tolerances and precision that I could do necessarily within a higher end CAD piece of software, but I can get to designing pretty quick.
Yeah. So I would say if you're going to go down this journey, the first thing you need to buy, good set of calipers. What are calipers? Calipers are a little slidey device that measures distances and gives you a digital readout in millimeters of how big something is.
Yep.
For everything that we're doing here, making a Stream Deck mount, making a bracket to hold something in your rack, doing, adapters for cable management, things like that, you're going to want to be able to measure something in the real world quickly and easily and accurately, and then translate that into the software. That's kind of the biggest like brain shift you're going to need to do, is that normally when we're working creatively in software, we're not working to any reality, right? We're just all in here in picture land, right? With CAD, we're talking real measurements. If you make a 10 millimeter square in CAD and then print it on a 3D printer, it will come out 10 millimeters wide. So getting a good, and they're not expensive, you can buy them on Amazon, but just get a set of calipers so you can start measuring things that you're going to need to make.
Yep.
Then, start playing around in CAD software. There's very, very much levels to this. There's super easy drag and drop, like template-based CAD systems out there that are free online, basically. There's open source solutions, and then there's more advanced systems like Autodesk Fusion 360, which I use, which has a community free version that is more than powerful enough for anything you're going to want to 3D print in your office. And then from there, you just go, like we said, through the slicer software, through the 3D printer. Just be ready to try again and try again and try again and fail.
I also think it's worth mentioning, Joey, that if your brain doesn't necessarily work that way, the communities for objects, models, if you will, is just astronomically huge, right? There are websites, we'll put these in the show notes, but things like printables.com, Thingiverse, I mean, there's probably dozens of them other ones where people who are much better designers than we probably are, oftentimes, not always, but oftentimes, they got a doohickey, they put that design up online. Sometimes it's editable design for you to use. Oftentimes it's kind of the output of that design, what's called an STL, or sort of the CAD file, the render of that CAD design itself, for you just to download, put it right on your printer and print, right? So sometimes, like, if I'm like, well, I can spend 4 hours trying to figure out how to design this, or I could go find the thing that is most like the thing I want, or in better case, the middle ground is I found the thing that I want to print, but I need some modifications. I can then have the best of both worlds, where I'm kind of modified it.
Yeah, and that's the thing, right? The community is getting bigger and bigger. We talked about this a little bit earlier, where it used to be a hard thing to get into 3D printing. It's gotten easier and easier and easier. The community's gotten bigger and bigger and bigger, and started to include more post-production professionals. So if you look on Thingiverse and you search for Stream Deck mini panel holders, you can download my design and print it out.
Yep, totally.
And it works great. My Stream Deck holders exist in some very high-end color suites around the world, because other colors have come out to me and said, hey, either A, could you print one for me and send it to me? I love the idea of it. Or B, can you just send me the file? I just got a 3D printer. I want to do it. And that's where it gets really cool. That's where it really is the Star Trek replicator. Because the other day, Robbie was building his own tape backup mount for his NAS, right? Again, DIY hardware, right? And he needed a bracket to fit a SAS connector board in this chassis. He drew a sketch on a napkin, took some measurements with a caliper. I went into Fusion, designed him a part, emailed him the part. He printed it out on his end. I've never held this thing in my hand. I literally emailed Robbie a physical object, and it's now in his rack, actually working.
And the thing
it's not a complicated part, right?
It's not, but the issue with that is that, like, I could have spent a lot of money trying things out. Oh, this is sort of fits the bill. Oh, this is this bracket. I could have waited for shipping. I could have waited spent the cost of doing this. We went through maybe one or two iterations where I just said, "Hey, can you just move the screw holes back a millimeter or whatever?" After trying it because you didn't have the piece in hand, and it was perfect. And that was a functional slash problem solving kind of thing that honestly I wouldn't have had a solution to without a 3D printer, because there was nobody is making, oh, you need a riser block for a one-use server to fit this specific SAS card. I mean, come on, right? Like that doesn't
Yeah.
exist, So it's like it's a piece of cake. So let me ask you this though. So when you get into that kind of 3D printing and you're maybe going to a website like Thingable, Thingiverse or Printables or one of these other places, can you just speak to, because I think this is a little confusing to people getting into 3D printing. So you'll find things like STLs. You'll find files that are like 3MFs, I believe is the extension on that. But what are those files? Because those are not the actual like CAD design files, right? Those are the output.
Exactly. It's kind of like rendering an image out to a flat file, right?
Right.
So in CAD, you can change the dimension of one line or one face, whatever. An STL or a 3MF file is all of your CAD geometry distilled down to discrete triangle surfaces so the slicer can read it. They're very not editable.
Right.
So if you're doing your own designs, you'll be doing them in CAD, and then you'll just export the STL and then use that to slice it and prep it for the printer. Most things you'll download from the community are also STLs, so they're a little harder if you wanted to go in and edit them, but you can make
You can do
small
like
modifications.
Yeah, basic scaling. Like you could add if you needed to put some text on it. You can do.
Yeah, you can scale, you can
slicer.
invert, you can do a lot in the slicer while you're prepping it to print.
So if you're out there looking for a 3D printer, right? I mean, there's literally hundreds of models that you can choose from companies like Versa and Bamboo Labs and Creality. And like, just do your homework. I mean, there's going to be certain things that separate these printers. Build volume, how big of an object you can print is one really kind of discerning factor. Multi-material support, whether you can support multiple filaments like I have back here in a single print. So if you wanted to change color on a print for a particular part of it, or have a different type of material on a certain part of the print, that's a big distinguishing factor. Speed, of course, is a factor. How fast it can actually speed out things, and what materials it can print. Like certain materials are only really good for certain types of materials. You might have to have an enclosure to print more advanced engineering materials because of the smell of them. And actually, that's the last thing I think we should mention about 3D printing, just so we can put the asterisk for the legal disclaimer here. 3D printing, as Joey said, is melting plastic. No matter what material you're using, it is melting stuff with a lot of heat to do so. And therefore, it is possible to create fumes and byproducts, those volatile compounds, from printing something. So just so you know, a lot of entry level filaments, totally fine, probably not going to cause you any problems. I'm thinking PLA, PETG, whatever. Some of the higher end engineering formats are pretty dangerous to get into your system by inhaling. So you want to make sure you have proper ventilation, a proper enclosure. A lot of people kind of put these things out in a garage or out in a room where they have a lot of ventilation. But just know that it's not something you necessarily probably want to have going on next to your bed while you're sleeping, kind of thing. And also, the other thing I would just say about 3D printers in general is this is not an instantaneous procedure. It has gotten better at how well tuned these things are, but it can give you some problems. And the communities are great for troubleshooting, but you see horror stories all the time of people just end up with piles of gobs of filament in a pile. Why does that happen? There can be a million reasons. We're not here for help desk support on that kind of stuff. But it is a little bit of trial and error. And as you get better and more advanced with it, you start to understand, oh, well, yeah, I can't print a 6-inch piece of overhang in thin air because there's nothing underneath of it to support it, right? You start learning techniques about supports and layers and how to orient things to print and that kind of stuff to get the best results out of them.
Yeah.
Um,
So what happens though when you need something
well,
out of metal
this is
or
what I was
something
going to
that you
ask.
can't print?
So this is what I was going to ask. I went down this path with a guitar story I was telling you earlier because I wanted to make my own guitar bodies. And yes, there are some 3D printable guitar bodies out there. I have one. It's pretty freaking cool. But wood, metal, etc., we're gonna have to go to something slightly different. And I actually, this is a really good distinguishing factor. With 3D printing, what are we doing? We're taking a material in one form and we're basically, met through morphine, whatever, into another form. We're taking the plastic,
It's
melting it,
additive.
making it into something. With other materials, wood, metal, etc., it's the opposite way of working, right? We're starting with generally a block of something and we're taking away, we're subtracting from that material to make the object. Wood is a great example. Start with a block of wood for a guitar body, you cut it out into the shape you want, you sand it down, you're taking away to get to the same thing. And the same thing is true with metal.
Yeah. So where does that fit into the post-production world? For me, it's things like monitor stands,
Yep.
modifying your desk, keyboard holders, stuff like that that need to be a little bit stronger. Once you kind of have this foundation of I can design the part, again,
Yeah.
all at the end of it, it all starts with the idea, right? So if you have an idea for a part and you know you're going to need it out of metal or out of wood, and you're probably going to need to contract that out and have someone else build or manufacture your designed part, 3D printing can be a great prototype for that.
Cool.
Case in point, Robbie and I both have 31-inch Flanders Scientific monitors. We had one at our office as well. And we have at all three locations the same TBC Consoles desk that has a rail system for mounting monitor arms. Nobody made a monitor arm that was heavy duty enough and strong enough that we trusted putting our big, heavy $30,000 monitor on. So what we did, I got the measurements from the engineering drawing from Flanders of the screw holes in the bottom of the monitor where the feet bolt into it.
Right.
Right. And what we ended up doing is we made mounts that fit into just a straight upward pipe coming from the TBC desk.
Yep.
And replacing the feet on the Flanders monitor. So the monitor could just drop down on these two pipes where its feet used to be and sit on the desk. So that is a completely one-off mounting solution for this monitor that makes it fit exactly where we wanted it on the desk physically, both height-wise and distance-wise. It's very robust. It's very low profile, so we can still get our cables around it and everything like that. And again, it's something that you cannot buy anywhere. Well,
Yep.
we went through 3 or 4 3D printed versions of that, and we never put the monitor's full weight on them because we wanted them to be metal, right? So we kind of 3D printed the part to figure out how it would fit, and then we went to someone else to get them actually cut out of aluminum. Now, I'm fortunate. I have a very good friend who has a machine shop, and I have access to a CNC machine where we can get these things machined. What a CNC machine is computerized numeric control. It's essentially, like Robbie said, it's the opposite of additive manufacturing. It's subtractive. You take a block of material and you use a robot to cut out the parts you don't want out of metal, wood, carbon fiber, whatever. And then you end up with your 3D object at the end. So what we ended up doing is we took the design, 3D printed it, prototyped it, locked it down after a couple iterations, and then had my buddy CNC machine it. And now we have that at home and at the office, and it's been there for years. We've never had a problem. The monitor is on there really good, and I love it. It takes up so much less space than like a conventional riser or a shelf or something like that. And again, we were able to customize it to exactly what we wanted. It's funny. We were talking like, should we sell these? I'm like, well, you kind of have to buy a very specific $5,000 desk and a very specific $30,000 monitor just to even think about wanting this. Well, the target market here is kind of you and me. There are also online services that specialize in this. So if you've got a 3D printer and you figured out your design and you've prototyped it and you've held it in your hand and you said, okay, this is what I want, there's options to email that file off to a service and have them do it and send you back the part. Cut Send or Send Cut Send is one. Yep. PCBWay is another. We'll link some more in the show notes. But what they'll do is, if you've got a design you're happy with and you want it out of metal, You'll email them the part. You'll say what you want it made out of, how many you want. They'll tell you back a price, and that's it. If you like the price, you say yes, I'll take it, and they'll do all the work and send it to you. And that brings me to kind of like the last category of part that I think is good for DIY, which is what I think of as kind of the 2.5D part. It's a flat something that you cut holes into or cut designs into. And there is a lot of places like SendCutSend that will do water jetting or laser cutting of things in basically any shape you want. So you can have, a sheet of 1/4 inch thick aluminum that you cut brackets out of, for example, if you wanted to make a monitor stand. In that case, you're only making a 2D design because your 3D is just the thickness of the material, but it opens up your options to make things like if you needed to adjust something how a rack mount works, or if you wanted to make a table to put your monitor on or something like that, you could do it out of metal from a 2D shape as well.
Yeah, and there's certain reasons to use those services. I'll give you a great example. The desk that I'm sitting at right now, I wanted something that had, because I have a little bit of a belly, I wanted something that had a little bit of a belly cutout, but I couldn't find anything in the right length, right? So I have a friend that has a little bit more of an advanced woodworking shop than I have, right? And I don't want to spend all that money on tools I'm going to use once, right? And so I wanted something that was like progressively beveled for like the belly cut. And he was like, yeah, no problem. So I just literally sent him just the same thing. I sent him the CAD design and he just took it. He's like, well, I can make this a little smoother, a little better. And I have the right tool to do this bevel. I took literally a piece of 3/4 inch plywood. He did all the cutout and beveling, shaped the edges for me, put some screw holes in the bottom of it, fit to the feet that I already had, and just bam, now I have a custom desk that literally cost me $30 or $40 at Home Depot to buy the higher quality plywood, and a case of beer with my buddy to cut it out. So it's a win.
Yeah. So back to the very beginning here, it all starts with the idea. And once you kind of open your mind to, hey,
Yeah.
there's something that I want, or there's something that I need for my office, for my house, for my work, for whatever,
Yeah.
and it doesn't exist off the shelf, your first thought should now be, well, how can I make it? Or how can I make part of it and get the other part made? Or how can I design it and get the whole thing made? Just open your mind a little bit to the possibility that, yeah, hardware can be DIY now. The world has kind of really advanced in this field in the past 10, 20 years. And it really does kind of change the way you think about building out your office and your workspace.
So Joey, I know it might seem to people that we're not talking about anything post related. We're just, oh, cool, print a 3D cent. Like, the purpose of this series and this episode in particular was just to get you to think about the possibilities, right? Of what is possible to do. If you start doing research on this, you'll soon realize like the sky is literally the limit. I talked to somebody the other day who had DIY'd a motorized lift for their panels. So they wanted to have the desk work so when they were not coloring, it was a flat surface. So they actually cut into their desk, bought some hardware. I don't think they printed it. Bought some hardware that basically opens and closes a hole in the desk and then raises the panel out of the bottom of the desk. Now I know what you're thinking, who cares? That's stupid. Why would you need that? But
I kind of want that.
The point is you can, right? There is, as we started the show talking about, there is a certain satisfaction that happens with knowing that this is completely customized and this is a one of one and you made that thing, whatever it may be. And part of it can be ergonomics, aesthetics, but also part of it's functionality, right? Is getting that, Joey couldn't ever get a off the shelf Stream Deck stand that was going to be the perfect height and configuration for how his ergonomics work. The only way he was ever going to get there was to design one and print one himself. And so, I think it's pretty cool. So good stuff, Joey. And just up in the next episode, we'll talk about how this all parlays into software. We'll talk about some more about that Home Assistant stuff. We'll also start getting into more about scripting and how ways to customize tools like DaVinci Resolve to do more workflow automations and things of that nature that can help you speed up things in your own projects. So, As a reminder, the podcast is available on every major platform out there. We're also on YouTube. Follow us on the various social medias just by searching for the Offset Podcast. And if you do find the show, please like and subscribe. Tell your friends and colleagues about the show. Every little bit helps in a major way. So for the Offset Podcast, I'm Robbie Cronin.
And I'm Joey Deanna. Thanks for listening.